Assalamualaikum and good day. You are with me again, Miss Huda. In this video, we're going to continue on the principle of moment and we're going to learn on the calculation part. Without further ado, let's continue. Find the clockwise and anti-clockwise in the figure. There is an illustration here that's showing a beam with loads, 4 loads in total, and we need to calculate the total moment. And the question also asks you to identify whether the beam is in the state of equilibrium or not. So we're going to use the moment of equilibrium principle. First, here I wrote that sum of moment at the fulcrum equal to 0. It means that the moment at the fulcrum akan jadi kosong. Maksudnya dia adalah equilibrium. Which means that clockwise and anti-clockwise moment adalah sama. Jadi dia equilibrium. We're going to identify which force that will produce a clockwise moment. We know that 150, if we're going to take the moment to the fulcrum here, is going to be clockwise. And 30 Newton will be clockwise. 150 Newton to become a moment, because we know that moment is equal to force times distance. Force is 150 and the distance to the fulcrum is 150 mm. The 30 Newton, the distance to the fulcrum is 360 mm. It will be equal to the anti-clockwise moment, which is 45 and 75 Newton. 75 Newton you have to times with the distance, times with 300 mm, the distance to the fulcrum, and 45 Newton times with 240, which is the distance to the fulcrum. Okay, all the forces you have to include in this calculation because we know that forces produce moment. Right, so we calculate everything here. Then you will get 33,000, which is clockwise moment, and 33,300 for anti-clockwise moment, which means that this value is sama, meaning that this is in the state of equilibrium. Moving on, we go to example number 2. A uniform rod is in equilibrium under the action of the weight as shown in figure 1. Calculate the value of W and the reaction at the fulcrum. Ignoring the weight of the rod, meaning that kita tak perlu pedulilah pasal rod di atas fulcrum ini. Ignore sahaja. Kita just have to find value of W here. Okay, so if anything, kita akan take moment dekat fulcrum. Sebab fulcrum ni lah kita nak tahu whether dia in a state of equilibrium or not. So, fulcrum ni yang menentukan. Jadi, berapa weight yang kita boleh letak on the W here so that the rod is in equilibrium. Right. First, kita akan identify which one yang clockwise. Okay, so jalan kerjanya sama saja, which is moment at fulcrum is equal to 0, clockwise equal to anti-clockwise. Right, so di sini adalah semua clockwise moment. And over here is anti-clockwise moment. Right, so for clockwise moment, we know that we have 30 Newton and another 30 Newton. And the distance will be, for 30 Newton, the first one will be 200. And for the other 30 Newton is going to be 400. Sebab dia ke fulcrum ya. Okay, so inilah dia. For the anti-clockwise moment, we have the W that we're going to find kat sini, the W here. So dia nak ke fulcrum, it will be anti-clockwise moment, which means that the distance is going to be 300. Therefore, W darab dengan 300 mm. Di sini, you have 25 and 20, which is 25 darab dengan 250 and 20 times with 150, the distance to the fulcrum. This is all here, right? So kita solvekan everything. 6,000 Newton mm plus 12,000 Newton mm for clockwise moment. And for anti-clockwise moment, you have 300 W, sebab kita nak cari W, so W it is unknown. Plus with 6,250 Newton mm plus with 3,000 Newton mm. So simplify all this, then you get something like this. And boleh tak you cari W? Boleh ya. So this is how you carilah 8,750 Newton mm bahagi dengan 300 dan you akan dapat W. Okay, pangkah-pangkah ni dan tinggallah Newton unit dia. Therefore, it is 29.167 Newton. That is the value of W kalau the system ataupun rod itu berada dalam state of equilibrium. Example number 3. A plank of uniform cross-section 4 meter long, weighing 300 Newton, has a support placed under it at 1.2 meter from one end as shown. Calculate the magnitude of the weight W required to cause the plank to balance. Okay, this plank need to be in balance. So the question asks you to find the value of W here, provided that you have the self-weight of the plank itself 300 Newton. So 300 Newton ni dekat mana? Is it here? Is it here? Is it here? 300 Newton ni adalah plank ni punya weight. And since dia dah dalam Newton, okay, normally if you look at plank, we know that it is uniformly distributed load. I know that kita dah belajar dalam teori. So you dah tahu apa itu uniformly distributed load. For example, beam adalah uniformly distributed load, dia punya self weight. So sama je, sepanjang-panjang berapa L meter dia ni, weight dia sama. And in this case, dia dah bagi dalam 300 Newton, meaning that berat keseluruhan plank ini adalah 300 Newton. Dia bukan untuk setiap 1 meter lagi. Okay, so kalau kira untuk setiap 1 meter, meaning that 300 Newton you kena bagi dengan 4 meter, which is this is the length untuk setiap 1 meter plank. Right. So here dia dah bagi 300 Newton, it is the total load of the plank. Okay. So bila dia bagi macam ni, you know that bila you kira, it is from the centroid of the plank. So kat mana centroid of the plank? It should be dekat center dia. Maksudnya, you have a 4 meter long, means that the centroid should be here lah. Ini 2 meter, ini 2 meter. Okay, betul-betul dekat tengah. Right, so dia turun ke bawah. As much as 300 Newton. So this is how we going to identify lah macam mana sebenarnya load. Okay, total moment at fulcrum again, because of equilibrium, is equal to 0. So clockwise is equal to anti-clockwise. 300 newtons times 0.8 equal to W times 1.2 meter. Alright, what does this mean? First, kita akan identify clockwise dulu. So clockwise, okay. Tengok dekat sini, we don't see any other force except that this 300 ni, kalau you tengok dalam gambar ni, tengah-tengah dia tu adalah dia betul-betul kat tengah-tengah plank ni, meaning 2 meter from the left and 2 meter from the right. Right, so 300 Newton nak ke fulcrum, okay, the distance akan jadi berapa? 0.8 meter. Okay, sebab ini 2 meter ni dari kanan. Jadi ada 2.8 minus 2 meter dapat 0.8. That's why 300 newtons times 0.8. That is the clockwise moment, the only one. This one, right? And another one that we're trying to find the W. So W, it is anti-clockwise. It is obvious, okay? So dia pusing macam ni. Arah lawan jam nak ke fulcrum. And the distance is 1.2 meter. Therefore, you akan dapat 1.2 meter times with W. Right. So 240 Newton meter, okay, equal to W darab 1.2 meter. Then you can get the value of W. It is 200 Newton. And kalau W dia 200 Newton, plank tu akan stable lah, which means dia akan in equilibrium. And we have the example 4 here. A uniform rod weighing 100 Newton and supporting 600 Newton in hinge to a wall and kept horizontal by a vertical rope. As figure below, calculate the tension in the rope and the reaction at the hinge. Right. So previously we have learned about the connection and we know that there is a roller, pin, fixed connection, fixed support. In this case, if it's hinge, meaning that it is pin support. So the question asks you to find tension dekat rope ni dekat and reaction dekat hinge. Kita identify dulu apa yang kita perlukan. Right. So when there is a pin support, you know that it can't resist moment because they allow rotation. However, it can resist forces, horizontal and vertical. That's why there is a Fy over there. And the other one will be Fx. Right. And rope, we know that kalau ada rope and ada force below, it is in the state of tension. Dia berada dalam keadaan tension ya. Sebab dia ditarik ke bawah. Dia ditarik elongate. Jadi that's why dia in tension. This is based on the, what we call it? Like observation and our common knowledge lah. Right. But sebenarnya kita boleh je assume dia in compression. Okay, boleh je you nak assume, you tak tahu, you nak assume, you assume. But later on you will get a negative value. Itu cara sebenarnya kita nak tahu our assumption is correct or not. But here, actually kita dah tahu sebenarnya. We can see that this is in tension. Therefore, kita assume dia go like this lah. Kalau compression, dia akan macam ini. Right? Masuk ke dalam. Kalau tension, dia akan keluar, ditarik. So, dia keluar. Okay. So, where we going to take our moment? Okay. So, usually when we have this kind of question, dia tak ada pun cakap in equilibrium and what not. But it's just that kita nak dapatkan the reaction and also what happened to the rope. So, kita akan gunakan moment equation. Kita akan take moment where we can take moment dekat hinge sini. Okay, why? Sebab when we want to solve any equation related to the moment, right? Kita akan try to take dekat the connection ataupun dekat dia punya joint. Okay, so hinge adalah the support, joint ataupun connection, right? So take it here. I take moment dekat hinge, which is equal to 0, clockwise equal to anti-clockwise. Right, so we have 100 Newton times 1 meter and 600 Newtons times 1.3 meter is a clockwise moment. Okay, so apa yang clockwise dekat sini if you take hinge? Right, one you have 600 Newtons going to the hinge. Okay, dia tak akan berputar macam ini ya. Ni jauh jarak dia kalau you fikir common sense lah. Okay, dia akan jadi jaraknya jauh. We're not going to do that. So 600 Newton times with 1.3 meter. This one. And you have another 100 Newton over there. So 100 Newton ni datang dari mana? Same. Sebab kita ada this 100 Newton macam example number 3. This is the self weight of the rod. Okay, so 100 Newton ni di mana? It should be at the center lah of this rod. Okay, pergi ke support ataupun ke hinge itu 100 Newton. It is clockwise also. And distance dia should be, kalau ini adalah 2 meter, then it should be distance dia adalah 1 meter. Di tengah-tengah rod Jadi 1 meter lah. 2 meter bahagi 2. Di sini. Okay. Okay, itu on the clockwise moment. And we have anti-clockwise sebab kita nak solvekan the value of tension yang the rope tu having sebab rope tu adalah in tension. So ada reaction dekat sini, dekat rope ni. Right? So rope ini dia akan pergi sebab rope ni dia naik ke atas kan. Tension dia ke atas. Okay, jadi dia akan pergi counter clockwise. So counter clockwise, it is berapa value dia, kita tak tahu sebab kita tengah cari tension. And the distance is nak ke hinge adalah 2 meter. Therefore, R darab 2 meter. Here the tension, we call it R lah. Kita solvekan, we can get the value of R, which is equal to 440 Newton. That is the value of the tension that the rope is having. Next, we going to find the reaction dekat support ataupun connection itu. Because the question asks you to do so. Ni ya. We know that tadi kita dah pecahkan. Kita tahu hinge adalah equal to pin and it can't resist moment. Meaning that takkan ada reaction of moment dekat sini. However, it can resist vertical and horizontal forces. That's why ada Fx and Fy. Okay, you boleh calculate mana-mana you suka dulu. But for me, I selalu calculate for Fy first. So we know that whatever yang naik ke atas, kalau dia nak jadi equilibrium, dia mesti ada juga reaction yang turun ke bawah. Ataupun the other way around lah. Apa yang turun ke bawah akan sama dengan apa yang naik atas. Then it is in equilibrium. Right. So total Fy, maksudnya total forces arah Y lah, will be equal to 0, meaning it is equilibrium. Right. So apa ni atas sama dengan bawah. Okay. So here, dia panggil hinge hinge plus R sama dengan 100 Newton plus 600 Newton. Hinge dekat sini adalah apa yang saya tulis dekat here adalah Fy lah. Okay, ini dia tulis hinge dekat dalam equation. But up to you, you boleh namakan dia Ry pun boleh sebab dia adalah reaction pun boleh juga. That doesn't matter. Okay, so as long as you know and you label it dan you tahu itu apa, then it's fine. Right, so Ry going up. Okay, kita assume dia naik ke atas. Okay. Jadi going up, it is yang naik ke atas, kita tahu ada positif. Okay, it is forces yang naik atas. And kita pun dah kira rope ni, masa kita kira and kita assume dia adalah anti-clockwise maksudnya dia naik ke atas and kita dapat value dia positif. So memang rope ni dia punya reaction adalah ke atas. Okay, sebab dia positif. According to our assumption, kita assume dia naik atas. Kalau kita assume dia turun ke bawah, dia akan jadi masuk dekat clockwise masa kita calculate. And we going to get value untuk tension ni negatif. Meaning that sebenarnya dia berlawan dengan apa yang kita assume. Maksudnya dia bukan turun ke bawah. Dia adalah naik ke atas. So sebenarnya positive and negative here means something. You cannot just put positive, negative. That's why kita tahu arah-arah, the direction is very important. So that kita tahu arah mana sebenarnya those forces itu bergerak. Moment tu clockwise ke anti-clockwise. Like that. Okay. Hinge. And kita ada value of R juga sebab kita dapat tadi dia adalah positif. So dia arah atas. So ada reaction di situ. Equal to, okay, apa yang turun ke bawah? One, you have this 600 Newton. Okay, the load, and another one is the self weight of the rod, which is 100 Newton. Okay, so 600 Newton turun ke bawah, 100 Newton turun ke bawah. Okay, sebab ini adalah force equation. Kita tak perlu darab dengan distance. Kalau moment equation, you kena darab dengan distance. It is moment. Okay, ini adalah force equation. So, hinge ataupun if you name it RY pun boleh, ikut suka you. Plus R, which is the tension of the rope. Semua ini force yang arah ke atas. And force yang turun ke bawah adalah self weight of the rod and the load. And you can replace the value of the tension in the rope, which is 440 Newton, plus with hinge, equal to 100 Newton plus 600 Newton ataupun RY lah kalau nak namakan dia. And you can get the value of the hinge ataupun RY. 260 Newton. Right, and we know that there is another reaction. The hinge itu because we have this horizontal force yang dia boleh resist tapi kita nak tahu reaction dia berapa. So kita kena faham bila dia boleh resist that thing, meaning that there must be reaction. Kalau dia tak boleh resist, there are no reaction. So sebab dia tak boleh resist moment, tak adalah moment reaction dekat hinge ataupun pin support, right? Okay, so total force horizontal, okay, X is equal to 0. So any forces to the right will be equal to the forces to the left. So in this case, we don't see anything on the right or the left. Semua force tu vertical. Tak ada yang tu ke kiri ke kanan. Rod ni, dia ada reaction ini je. Yang lain tak ada. Unless you ada this kind of force, you ada macam ini. For example, dia bagi 40 kilonewton dan there is some value. Tapi since in this case, there is none, therefore, kita akan calculate dia tiada lah. Okay. Kosong untuk arah kanan dan kosong juga untuk arah kanan dan juga kosong juga untuk arah kiri. Equal to 0. There is no, you can use it like this lah. Rx is equal to 0. Reaction at X equal to 0. That will be the answer. Right, so that will be all. Thank you.